Hello to all students of BeaconHouse School from Faisalabad, Pakistan, and many thanks to Director of STEAM Vision Program, the Professor Fawad, for his invitation. We are very excited for your robotics competition. In this presentation, we will show you some of our robotics projects. We will try to inspire you and share you some of our passion for robotics and technology. I am Mauro D'Ambrosi, one of founders of DAM Bros Robotics team, a group of engineers, students and makers that love technology and robotics. Our goal is to spread robotics and teach it in various ways. We often organize workshops in schools and other companies and develop more about it. For our project, we often use 3D printing because with this technology we rapid prototype every idea that comes to mind. It's amazing to see when an idea passes from their mind to computer with CAD software, and from CAD software to real world with 3D printing. Each bit of a CAD model is converted into atoms and transformed to a real object. At the end of the printing process, all the pieces that were previously virtual have become solid and ready to be assembled. We realize chassis or wheels and all the other parts of our robots. It's amazing to see the transformation process that can life or idea.
Hi guys, I'm Marco D'Ambrosi from Numrous Robotics. I'm a robot builder and a student, and I'll show you some of our latest projects. This is our latest project, the Mimica hand, which is a prosthetic hand. It is really cheap and hyper realistic. It can be scaled to adapt to the human body. It is internally totally printed and covered by a silicone skin. This is the internal structure of a Mimica hand. It is designed to be extremely simple and very durable. This is a motor with a torque of 15 kilograms per centimeter. This is the internal structure of Mimica in motion.
The structure of robotic hand was designed to replicate the same functioning principle of bones, tendons and muscles of the human hand.
This is our first prototype of Mimica hand in motion. This is a controller that we developed to the theater, and it can be controlled also by a USB cable via ROS robotic operating system, via Wi-Fi, or through a smartphone control.
Vai.
The skin of all robotic hand has the same consistency of the human skin because it's made of the same type of silicone used for medical implants.
This is a glow controller based on flex sensor. It can be attached to an Arduino and it has an accelerometer and a gyroscope. It can control everything based on your hand, on the movements of your fingers. We have used the glow controller to control the in-move arm, which is all 3D printed and controlled by a wireless module, an NRF24L01. The arm is controlled by 7 servo motors with a torque of 15 kilograms.
The sensor on the fingers are able to transform the movements into variations of resistance, which are used to control the artificial tendons of the robotic hand in move. Engineers always take inspiration from nature, like Wright brothers for their planes, or like Leonardo da Vinci for his automatons. Robotics does the same, and when we develop a new product or a new robot, we follow the same way. In this example, we can see a little robot rover that has a similar structure like a little mouse. It has a brain to make decisions, wheels to go around, sensors to detect obstacles and interact with the environment. In one of the latest projects that we make, the Mimic exoskeleton, we try to capture body movements to control humanoid robots and virtual avatars. The Mimic project is simple to implement. We are using cheap and easy to find materials. There are also parts to print in 3D that are freely downloadable and replicable. When the operator wearing the exoskeleton performs a movement, the humanoid robot does the same thing, with the same amplitude and speed. A system like Mimic exoskeleton can be used by military to remotely destroy bombs, by scientists to remotely handle hazardous materials, or by workers to move heavy objects. The exoskeleton can also be used in rehabilitation. In fact, it's able to measure and record the movements of the upper limbs. The exoskeleton is equipped with an interface software that allows to view data collected by sensors and save them on your computer.
Hello everyone, I'm an electronic engineer and a lover of this matter. The electronics make a great contribution to robotics. With electronics we are able to give various senses to a robot. For example, with a microphone a robot can detect sounds. With a camera it is capable of detecting complex shapes, colors or images. With various types of sensors, a robot is capable of detecting many other things, such as voltage, forces, thermal images, magnetic fields, accelerations and many others. This is a prototype of sensors that we made to give the sense of a pressure to a robotic hand. These prototypes of sensors are made with common silicon and graphite. They can detect a variation of their resistance when their shapes change due to deformation. We can use them on a robot gripper to measure the force of closure and to handle hard and soft things with the same accuracy. Different shape and size of some sensors, like this or this one, can measure different ranges of pressures and forces. Like robots, many other things are controlled by sensors and actuators to create autonomous systems. For example, this is a self-controlled drill that stops automatically when it finishes making the hole. This is possible because it uses some sensors to control itself. An instrument like this could be used on space exploration robots to operate automatically without human intervention. A better example of autonomous system is the domotic home, which will be more intelligent and interact with the environment without human intervention. A domotic house can detect human presence, can measure the temperature of a room and automatically warm it or cool it, can control the opening of the windows, of doors, can cook foods when we are at working, can clean itself, and many other interesting things that make more simple everyday life.
This is a DAM bot, a robotic kit developed for schools. It has a full 3D printed chassis and 2 full rotation servos. It has a ultrasonic sensor and a microcontroller, a power bank and a USB cable. This is developed to be extremely simple to assembly.
Our DAM bots are equipped with different types of sensors, such ultrasound or infrared, which robots use to navigate the environment. Our DAM bot can move independently according to a specific programmed algorithm, or can be controlled remotely via Bluetooth. We are also contributing to develop of a project on autonomous vehicle robots named the Takitown AKS. This is a project derived from an original version made by Massachusetts Institute of Technology. This project is named as Takitown. The Takitown project and also its derivative version, Takitown AKS, has the goal to realize autonomously vehicle that can move around a reproduction of a city, the Takitown. Each robot, named Takibot, has a structure like this. We have developed the system to detect the line to follow the curve of a street, and the system to detect the road signs to stop a robot and to allow it to go away when the street is free. The goal of bot project is to create autonomous vehicle robots that are able to move freely around a city, respecting the human road code. At the end, I will show you a special thing, a robot that has a support for a sensor made in cardboard. You probably think that I am a madman, but I want to inspire you with a special thing. We don't need particular technology or tools. We have the powerful tools that a man won't need. Your imagination. So, I hope you a great competition and good luck.
Have a nice competition and good luck.
Good luck!